Today we're going to continue on with the arranging certain items, and we're going to start by arranging certain items, but we want to know how many ways that can be done if we put specific items in certain positions. So the first thing we're going to do is permutations with specific positions, which is just arrangements of specific positions, or with specific positions. So the way you're going to do these is kind of how we've been doing them in the previous videos, where what I would suggest is you actually write out the spaces. Okay, like how I've been drawing the lines, and then you want to fill in the specific position first, then go back and fill in the rest of the blank spaces. Okay, so let's look at an example. How many ways can Adam, Beth, Claire, and Doug be seated in a row if Claire must be in the second seat? Well, there's 4 people. I have 1, 2, 3, 4. And here's my specific position. I want Claire to be in that second spot. She's got to be in the second spot. So that's the position I'm going to fill in first. And what you're going to do is the number here should represent the number of possibilities of people or things that could go there. Well, there's only one Claire. There's only one person in that group who's Claire. So there's only one possibility for that. Then what should happen is the number of spaces that are left should correspond to the number of people or things that are left to arrange. So let's say you take Claire out of there because you've already used her. Don't you have 1, 2, 3 people left to arrange? So I have 3 people that could go in the first spot, 2 people left to go on the other side of Claire, and 1 person left to go in that last spot. So the number of ways that we can arrange these 4 people if we put Claire second is 3 times 1 times 2 times 1, which is just 6. So there's 6 arrangements we can make with Claire being second. Part B, we're going to start over. Okay, so this time I want to arrange these 4 people, but I want a girl in the first seat and a boy in the last seat. So 1, 2, 3, 4. I want to put a girl first and a boy last. So what I'm going to do is fill in these specific positions first with the number of possibilities that could go in each spot. How many girls do I have to choose from to put in that first spot? Well, there's Beth and Claire. So there's 2 girls I could put in the first spot. Now I'm going to go to the end and fill in the boy, the last specific position. How many boys do I have to choose from? Well, there's Adam and Doug. So there's 2 boys I could put in that last spot. Now, again, what I said is the number of spaces left should correspond to the number of things or people or items that you have to arrange. So if you have 4 people, you used a boy, you used a girl, that means there's 2 people left to arrange. So I have 2 other people I could put in the second spot and only 1 person left here. So 2 options for the girl, 2 options for the boy. Assume you've used a girl and a boy. That means 2 people are left for this spot and only 1 person's left here. So if I multiply all these, 2 times 2 times 1 times 2, that gives me 8. So there are 8 ways to arrange these 4 people if I have a girl first and a boy last. Let's look at our next example. How many ways can you arrange the letters in the word kitchen if, and then I have a couple of situations. Well, there's 7 letters in the word kitchen. So 1, 2, 3, 4, 5, 6, 7. So our first example, I wanted to start with the letter T. So in the first spot, I want a T. Well, if you look at the word kitchen, there's only 1 T. So there's only 1 option I have to put here. Well, if there's 7 letters and you use T in the first spot, then you only have 6 letters left to arrange. And there are 1, 2, 3, 4, 5, 6 empty spots. So there's 6 letters that could go here, 5 in the next, 4, 3, 2, down to 1. So the number of ways I can arrange the letters in the word kitchen if T is first is 6 times 5 times 6 times 5 times 4 times 3 times 2 times 1 times that 1 in the front. If you really want to put that there, you can, which this is really just 6 factorial. There's 720 different ways I could arrange the letters in the word kitchen if T is first. Okay, part B, again, I'm going to start over again. So I'm going to do 7 new spots. Okay, this time I wanted to start with a consonant. Okay, do we remember consonants versus vowels? Because in letter C, I'm going to ask about vowels. So, okay, remember a vowel would be like I or E. So in the word kitchen, you have 2 vowels, which means you have 5 consonants, K, T, C, H, and N. Okay, there's 5 consonants. So again, I want to fill in that specific position first. How many consonants do I have to choose from to put in that first spot? There's 5 possibilities that could go there. Okay, so there's 5 possible consonants that could go in that first spot. Now what you have to assume is that you've used those 5, you've used one of those 5 consonants. So what you should have left is 6 letters to arrange. And if you look, I have 1, 2, 3, 4, 5, 6 spots. So I have 6 letters that could go here. 5, 4, 3, 2, 1. So again, if you do these correctly, the number of blank spaces left should correspond to the number of things, people, letters, whatever you have left to arrange. Okay, so 5 possible consonants for the first option. You use a consonant, so that means there's 6 letters left to arrange. So I'm going to do the shortcut. This is 5 times 6 all the way down to 1. That's 6 factorial. So I'm going to do this as 5 times 6 factorial just to kind of shorten it up. And that's 3,600 different ways. Okay. All right. Last example that has to do with this word. So I'm still arranging the letters in the word kitchen. Okay, so I have 7 letters that I'm going to arrange. This time I want it to start with a vowel and also end with a vowel. Okay, so here you just have to be careful. I already know that there's 2 vowels in the word kitchen, so I'm going to fill in the first one here. How many vowels do you have to pick from to go in the first slot? Well, you've got 2 vowels, okay? But if you go to the second spot, all the way at the end where you want your other vowel, you have to assume that you've already used this vowel. So don't you only have 1 left that could go here, right? 2 could go in the first spot. But if you use 1, then you've only got 1 left to go here. Okay, now what you have to assume is if there was 7 letters, right, and 2 of them got used, you've got 5 letters left to arrange. And there are 1, 2, 3, 4, 5 blanks. So 5 letters could go here, 4, 3, 2, 1. So the number of ways I can arrange these letters so that the first and last one is a vowel is 2 times 5 times 4 times 3 times 2 times 1, which is 240. Okay, so make sure you're filling in those specific positions first, then fill in the remaining blanks with the number of objects or letters or people left to arrange. Okay. Let's look at one more example before we move on to a different topic. So phone numbers consist of 10 numbers made up of the digits 0 through 9. All right, now we talked about how those are 10 digits. Okay, how many phone numbers are possible if it can't start with a 0 and if 7 must be in the 4th position? Let's assume repetition of numbers is allowed. Okay, so we've got a phone number that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, okay? Now the numbers 0 through 9, there's 10 numbers in there that we can choose from. But I've got to fill these specific positions in first. Okay, so my first position, it can't be a 0. Okay, so it can't have a 0 in the first position. And in the 4th position, I want a 7. So 1, 2, 3, 4. Okay, so no 0 in the first, and here it must be a 7. Okay, so let's fill these in first. So how many numbers are not 0? Well, there's 9 numbers that are not 0, right? The numbers 0 through 9, there's 10 digits. If I take out 0, I only have 9 options to put here. Now I'm going to move here. This must be a 7. Well, how many digits are 7? There's only 1 number that could go there. That's a 7, right? Now I'm going to go back and fill in the remaining numbers of my phone number. Repetition of numbers is allowed. So I've got 10 digits to choose from for my second number, 10 digits for the next, and actually all the others I also have 10 digits to choose from. There are no restrictions on repetition of other ones. I just know that the first number can't be 0, so I only have 9 options for that one. And the fourth number has to be a 7, so there's only 1 option there. All the others have 10 options. So if I type this in, 9 times 10 times 10 times 1 times 10 times 10 times 10 times 10 times 10 times 10. Let me just make sure. 1, 2, 3, 4, 5. 3, 4, 5, 6. I need to make sure I have that 1 extra 10 there, which I do. Okay, there are 1, 2, 3, 2, 3, 4, 5. Okay, there are 900 million different phone numbers that I could make that do not start with the number 0 and where there's a 7 in the 4th spot. Okay, so all of these got multiplied together. Okay. All right, so that takes care of specific positions. So the last thing I want to talk about in this video is what happens if we just want to make a group of objects? Like now I don't care about the arrangement. Like maybe there's 10 kids in my class, but I just want to pick 4 kids and send them down to, the office, right? Or maybe I want to pick 6 kids and put them in a group to do a group project. I don't care the order in which I pick those people. I just want to make a group. So that's what's called a combination, is a grouping of objects. That's where we don't care about the order. So as soon as you see me say, how many ways can you make a group? You are going to use the combination formula, which is NCR, which is given by n factorial over r factorial times n minus r factorial, where n is the total number of objects and r is the size of the group that you want to make. Now, just like with the permutations, we could just type this into our calculator. You don't really need to use this formula. The only thing I'll say about the combinations is you're not going to write spots out and fill those spots in, because I don't care about what goes in the first, second, or third spot. So for these 2 examples, or anytime you see me ask how to make a group of things, you're actually just going to use the formula in your calculator. We're going to have the calculator do it for us. So I did post a document showing you how to put it in your calculator, and also gave you a website in that document to go to a combination calculator if you don't have that option or feature in your calculator. Okay, so let's look at number 4 and 5, and you'll see how different they are than the other problems we've been doing. Okay, a group of 18 people need to take the elevator to the top floor. The elevator can only hold 6 people. How many possible combinations of people are there for the first trip? Okay, well, again, does it matter the order in which I put those 6 people into the elevator? No, I just need to make a group of 6 people. So if I have NCR, this is 18 because that's the total number of people. I like to, when I say C, I kind of think of it as choosing. Like I have 18 and I'm choosing 6 people from that group of 18 to make a smaller group. So I'm going to do 18, math, go over to the probability key, and this time I'm going to select option 3, NCR, and R is 6. So 18 was the total, 6 people in a group for that elevator. So there's 18,564 groups that I could make, or combinations that I could make of 6 people to send in that first group up the elevator. Okay. All right. Let's look at example 5. Cody has homework assignments in 6 subjects, but he only has time to do 4 of them. How many possible homework combinations could Cody do? So, right, he's got 6 subjects of homework to do, and so he's only going to do 4 of them. It does not matter which order those 4 are in. If I wanted to know in how many ways could he do the 4 assignments, that's a different problem. I just want to know how many ways could he pick 4 of these subjects to do. So I have NCR, so I have 6 subjects. He's going to choose 4 of them to do. The order does not matter. So I'm going to do 6 math, PRB, 6C4, NCR, sorry, not probability. And there are 15 different combinations of homework that he could do from those 6 subjects. Okay, so in today's Schoology practice, you are looking at just specific positions. So like examples 1 to 3. Okay, so, you know, the work that I should see for the first problems on Schoology would be something like this, where you're setting up the slots, you're filling in your specific positions, and combinations. So as soon as you start saying, okay, here's a group of people and you're going to make a subset, or how many combinations of there are there, really the only work you're going to show me is what did you type into your calculator to get that answer.